All right, so before we get into Chapter 1, the importance of MIS, I would like to kind of add some front material to it because it's kind of disappointing. MIS is not a well-known discipline. Mostly we get, when freshmen come in, they've never heard of MIS. When our advisors or our enrollment people go into high schools, students don't know what MIS is. In fact, it is one of those majors where not a lot of freshmen come into it. What happens a lot of times is people come in as management or computer science or engineering, they figure out what MIS is, and then they become an MIS major. So we know, it's kind of one of the problems with it is it's typically an acronym, MIS. Okay, so it's kind of a hard thing to define. If you're a PA major, well, you're going to become a physician assistant, right? If you're an education major, hey, I think you're going to become a teacher, right? MIS is more of a general degree, and it has 3 general words with it, so it's hard to define. So what we're going to try to do to start out to define MIS is we're going to take each of those letters, maybe define those, and try to bring that together. So obviously, you guys hopefully know what the M in Management Information System stands for. Management. What is management? Big question there, right? What is management? Come on. Taylor?
Organization.
Okay. So I think the best way to define management is kind of thinking about the verbs associated with management, right? Organization is definitely one of the verbs, yes? What else? What else do managers do? What else do managers do? Come on. They lead, very good. What else? What else do they do? And I don't care if you're a manager of the department of business, the business administration department, or you're the manager of the Pittsburgh Pirates, or the manager of a resort. Yes? Delegate, very good. What else? What else? I'm trying to think of, go ahead, sir. Eric? Plan, very good. We'll say plan. We'll say forecast, right? Because part of planning is, forecasting what's going to happen. All these things, okay? Management means, the art of conducting, directing, using finite resources the best we can, the most efficient way we can, okay? That's what management is all about. It really comes from, it comes from the Greek, means to lead by the hand, okay? So that's what management is all about. And it's a very general skill. It's a very general skill. How about the middle letter? Information. What is information? That's also hard to find. We know information when we see it, but it's kind of hard to define. What is information? What is information? Go ahead.
Statistics.
Okay, well, we can use statistical techniques to get information, right? Like if I say Aaron's grade point average is 3.5, that's information. Now I know he's a good student, right? I know, that's what information is. But how do we define it? What is information? I kind of talked about this even in Stat 301 yesterday. We talked about what's the precursor to information. What's before information? Yeah. Data, right? So all information is data that has been processed some way for consumption to make it easier to understand. Okay? And if we think about that, 3.8, your grade point average, that's the information. Now I know something. If we talk about the sales at the cart last semester were $20,000, we know something, right? There's a whole bunch of data that goes into that. And I used the same thing yesterday in Stat 301 because it's important. Data leads to information. Okay? Information leads to knowledge. Now we know something, and knowledge is power. Okay, knowledge is power. And once we know something, then maybe we can go out and gather more data and continue the cycle, right? That's why they call it the knowledge cycle. The more we know we don't know. And we go out and look for more data to understand this a little bit better. Okay, so that's what information is. How about a system? System, very general term, right? Your football coach may say, "Get with the system," or "We have a system here," or you're not doing things according to our system. This is how we work. So what is a system? What is a system? It's a way of doing things. Very good, sir.
It's a set, list of rules and things that you do according, and you run your company according to that particular set of rules.
Okay, particular set of rules. How about, does anyone remember in biology the definition? That's probably where the first time you hear about systems, like in your body. Like how many systems do we have in our body? You remember?
I don't know how many systems, but it's like different parts working together.
Very good. Like, I think we have circulatory, digestive. Wow, I get 2. That's terrible. Skin's a system, right? The brain system, neurological system, 4. I think there's 7. Did I say circulatory already? Skeletal system, right? Isn't there 7? Your call science. No, all right. That's why we're in business. Muscular system, that might be 1. Okay. So what she said was the definition that I was looking for. Okay. She said a set of interrelated parts working together for a common purpose. Right. A set of interrelated parts working together for a common purpose, like your digestive system. It's your esophagus, your belly, your intestines, your mouth. I guess that's part of the system. All working together to take food into energy, right? That's what a system does. A set of interrelated components working together to accomplish a purpose. And if we look further, there's all kind of talk about something called, systems theory. Okay, systems theory. Every system has, at the very general, has 5 things. Okay, 5 things. Every system has a purpose. It's the reason the system exists. Period. It's the reason, its purpose in life. Every system has a purpose. The system, our system is the football system, win football games. The purpose of the business administration department, if you looked at it as a system, is to educate business students. Every system has inputs, and every system has outputs. Now, when we analyze something as a system, and it has only inputs and no outputs, that can't really exist. That's called a black hole. There's always something coming out of a system. So if it has inputs, no outputs, we call that a black hole. Something's wrong with our analysis. If it has outputs but no inputs, also something wrong with our analysis. That's called a miracle. They call that a miracle. There's something, no inputs but they have outputs. Shouldn't happen. The other things a system has, and these 2 things kind of go together, are a boundary and an environment. And the environment are things outside the system that can affect the system. Okay? Things outside the system that can change the way it operates, can interface with it. And the boundary is what defines things outside the system. And we're going to do a little bit more with systems in a bit. But if we think about those 3 things at a high level, and they are a high level thing. Management, it's hard to define, right? We had to use verbs to define that. Information was kind of hard to define. We had to look at what came before information and say, hey, it's kind of, I know it when I see it. Systems itself, we said, boy, systems is very general. You can say we have a system for this, a system for that. But if you put it together, okay, what we're really talking about in MIS, okay, is the study of systems of information creating systems that help us manage. Okay? Systems that create information to help us manage. If you think about it, I'm the chair of the business department. Okay? I get reports on enrollment numbers, right? There's an information system that generates that and says, hey, our average class size in the School of Business is 18.4. That's an information system that helps me manage. Are our class sizes too big? Class sizes too small? Do I need to make some changes here? The evaluations of this particular faculty is on a 5-point scale is 1.2. Do we need to make an organizational change there? Is that person not a good faculty member, not a good performer? Do they need to go? Okay. That informs the manager of that. Okay? Information systems generate information for business professionals to make better decisions. To do these things like organize, lead, delegate, plan, and forecast, we need information to do so because knowledge is power. So let's take a look at the system thing a little bit further. And let's take an example of a non-information system. And then we'll start talking about information systems. Let's look at the School of Business as a system. What is the purpose of the School of Business? What is the purpose? Why do we exist? Why do we exist? Why does the School of Business exist? Mr. Myers? Us. Okay. Just you. That's why we exist. Have you? Okay, right. What is our, if we had a mission, we do have a mission statement. I don't know it. We have a mission statement, Dr. Fry crafted. What is our purpose, the system of the business administration?
To educate business majors to get jobs.
Okay. So our system is to perform what? Our purpose is to perform business education. That's what we exist for, yes? And Mr. Myers, what I was looking for, so that's our purpose, and you can write that a lot of different ways. But what you were looking for, you said us. That's important. Where would us be? When you say us, that's students. Where would you be? What are you? And?
Outputs.
That's right. So if you think about it, this is terrible stick drawings, right? But our inputs are what? Freshmen, uneducated, ignorant freshmen, I guess. And we're supposed to become out, hopefully, enlightened business professionals, right? That's our outputs, That's what's supposed to happen. That's a terrible hat. Okay? That's what's supposed to come out, yes? Okay? And if you think about it as a system, that's our inputs, that's our outputs. If you have inputs but no outputs, it's a black hole. If you have outputs, no inputs, it's a miracle. Every system has something like that. Now, if we talk about what's in our system, what's not in our system, the boundary, the environment, okay? What are things that affect the School of Business that really aren't part of the School of Business? What affects us? What's outside that affects us, but really isn't part of the School of Business? I can't control it. Dr. Fry can't control it. What are things? Go ahead.
Other school policies.
Okay, so if you look at it, St. Francis University's policies even, right? If Father Malachi says no class will be over 15, okay, that's a university policy. It's not really part of the School of Business, but we have to adhere to it. If the government says no more online classes, right? We're abolishing online classes. Well, we have to adhere to that policy, yes? If competition is such that, that I don't know, I'm not going to say it in school, but they rise up and they're better, right? That affects our system, yes? Everything outside our system that can affect the system. Now, if we talk about, so that's systems work. And a lot of people do systems work. If they have a problem, what they try to do, like any kind of problem, they say, let's look at it as a system. And let's analyze each of those components. And where's the problem, right? Maybe, what's the problem? Maybe we're letting in people that, I don't know, don't have the aptitude to do well. Or maybe, they're not learning well. Maybe that's not happening here. Because the outputs that we're measuring, maybe they're not where they need to be, okay? So where's the problem? So a lot of times we can analyze things with a system, an interrelated set of components working together for a certain function. Now, if we look at this in terms of MIS, and I'm going to skip ahead, we're going to come back, but I'm going to talk, it's something called systems thinking, okay? But you really don't need to know that at this point. But if we look at information systems, we can use a component model, a framework, to try to understand information systems. And information systems are different. This is not an information system, right? But an information system would be, I don't know, the payroll system that St. Francis employs, the MTO ordering system that she uses, an ATM machine. Those are all examples of information systems. The checkout register that Karen uses at the cart. These are all examples of computer information systems, generating information. But if we look at an information system, we can break it into 5 components. And we're going to use this model throughout this class. And you're going to use it when you talk about your article assignment. So it's something that's going to be familiar to you, because it's very useful to break things down into components so we can understand them, so we can work with them, so we can fix them, so we can purchase them, whatever it might be. Every information system consists of these 5 components, and they're in an order for a reason. First of all, hardware. Every information system consists of hardware. Give me an example of hardware. What's hardware? Probably learned that in Computer Science 101 or just, high school. What's hardware? Give me an example of hardware. Okay, the hard drive, that projector, the printer, the computer, the monitor. Think about things you can physically touch, right? Those are those components. Your phone, your iPhone, your Android phone, your smartwatch. That's all hardware, the physical components, right? The hard drive is part of that. DVD drives, scanners, conveyor belts. Those are all examples of hardware. How about software? Hardware versus software. How about software? What's software? We're going to talk about software, a whole chapter on software. Mark? Okay, it is like applications. Applications do something, right? You have an app that does this. It's my mapping app, so it helps me get from point A to point B. What software is in general is the code that tells the hardware what to do. It's programs, right? There's someone that programmed your application, like let's say your Google Maps, that says when someone types this in and hits this, we want to go into here, we want to look at this map, and we want to find the shortest route, right? Someone had to write code for that. That's what software is. Software tells hardware what to do. In Microsoft Word, I hit the printer. There's software that says when someone hits the printer, whatever's on this screen needs to go to a printer and print out, right? It tells the hardware what to do. And there's different types of software. There's what's called application software, and that's kind of what you talked about. Application software does a particular purpose, like Microsoft Excel, Microsoft Word. Any app on your phone is application software. What's the other type of software? Application software, and it really doesn't do a particular purpose. It just keeps the hardware moving and interfacing. You all have this kind of software on your iPhone, because I think 90% of you guys have an iPhone. What is the type of software besides the apps? What's the other piece of software? Sometimes it gets upgraded. Sometimes it downloads in the middle of the night. It takes 12 hours. You wake up and stuff's not like you expect it to be. Yes? Yeah, the operating software, right? The thing that controls all the components of your iPhone. It's called, and the iPhone one is iOS. That's the operating software. For the phone I use, it's Android, right? For the computer here, it's Windows. The operating software, okay, still tells the hardware what to do. Data. How about data? What is data? Data we know is raw facts, okay? It's part of the system. It's the, what I type into the computer. It's the spreadsheet that I have, okay? Data. Now, interestingly enough, okay, people usually think about these 3 things when they think about computers, when they think about information systems. They think about hardware, software, and data, like, oh, that's techie stuff. But an information system isn't just the tech stuff. On this side of it, these are all, these things, procedures and people are part of the information system. So, let's start with the further right, people. People are part of information systems. If we think about, I don't know, let's think about, here's a good example, we'll analyze this one. The Sheets MTO ordering system. You guys are all familiar with the Sheets. Everyone's ordered an MTO at some point, right? Okay. That's an information system. Okay, that's an information system. What are the people involved in that process? What are the people? Okay, the person ordering is a person, is part of the information system, right? When you touch that screen, you're part of that system. What else? Who else, Aaron?
The people cooking it.
Yeah.
I don't know if the cashier would be part of it or not, because you got to pay for it.
Probably, yeah, you got to pay for it. That interfaces to what's called the point of sale system. You give them your little receipt, and they say, okay, that's the number that comes in. But yeah, those are the people. Now, procedures are what then? What are procedures then? So we know what the people are. What are procedures? What are procedures? Go ahead, Alexis.
The system that people know before they do it.
Okay. So because people are part of this information system, they need to know what to do as well, right? And some of it is intuitive. Like the MTO ordering system is very intuitive. You walk up to it, you point, I want burger, right? It's pretty simple. It's intuitive. But most information systems aren't that intuitive. So if you're working for an organization, they might say, hey, we're going to a new, accounting payroll system. You're going to have to go to training for a week. Because we purchased this new information system, and you're the person that works with that system, you need to know how to work with that system. You need to know, where to click to do this and what to do in this situation. That's procedures. So if you think about it, there's kind of a beautiful symmetry to this model, okay? And this is the symmetry that you see. If I look at these 5 components, there's only 2 things that are actually doing something. There's only 2 components that actually do something. People and hardware, right? Hardware spins, hardware prints, hardware projects, hardware reads, okay? And people type things in, they can move data, they click buttons, they put their handprint up, they put their eye up to it, they put their, whatever it might be. So the things on the outer end of the 5-component framework, hardware and people, are called actors because they do something. They both do something. But they need to know what to do. So software and procedures are their instructions. Procedures are the instructions for the people, and the software is instructions for the software, right? The software tells the hardware what to do. The thing in the middle, data, is kind of like the bridge, right? Data is kind of the bridge between the two. So we want to work with this information. Basically, think about the Sheets MTO ordering system. And I'm old, I know. But before the touchscreen, does anyone remember how that worked? There's still a need for me to get the data of, hey, I want a burger or I want a sub to that person's, and I want lettuce and tomato. There's still that data need, wasn't there? Okay, so at one point you just told them, right? You're kind of, you're taught, I want that. You feel like a king. You're telling someone what to do. You know what I mean? I want this MTO. Then they went to like a little sheet. That was the information system, a little check boxes, and it was better, it was more efficient. And then they went to intuitive, but the data need didn't change at all, right? Data doesn't change that much. Data needs don't change that much. If you think about it, a lot of things had to happen with an information system for you and I to be here. St. Francis had to offer the class, they had to assign me to teach it, they had to assign a room for it to be listed in, and then you had to enroll it, right? There's a lot of data there. All those things had to come together so you could be sitting here today, right? And we could be teaching this class. That same data need was here in 1847. Now, it was like 7 Franciscan friars, and they were all just studying religion, but they still had to come together and say, you're going to take, Bible topics 101, I don't know what it was, but anyway, you had to come together. That was the data, right? So the data doesn't change much. The things around it do change. Now, I'm going to come back to this slide, but if we look at this, okay, how can we use this? Well, first of all, these systems have existed a long time. Information systems have existed a long time. The process of moving work, and that's what we want to do to be more efficient, the process of moving work from the people side to the computer side is known as automation, right? That's known as automation. Let's not have the person do it. Let's have the computer do the work. If we move information or processes from the human side to the computer side, that's called automation. If you think about an ATM machine, how did that happen prior to ATMs? How did that transaction happen prior to ATMs? We had to go in the bank, you had to talk to a teller, they had to get the money out of the drawer. Very much what was called a low-tech solution, right? Now it's a high-tech solution. That person, that teller is not involved in the situation, right? Get your money, get out of it. That's automation. What's the hardest part to change in an information system, do you think? Kind of says up there. But what do you think is the hardest thing to change? What's the easiest thing to change? Yes? People are they are, right? There's something known as organizational inertia. You will experience this as a manager, as a business person, for sure. Organizational inertia is the tendency to do what you've always done. People say, well, why do I have to change? It's working fine. Okay? Why do I have to do anything differently? People are hard to change. What's the easiest to change? What do you think? Go ahead.
The computer,
What part of the computer?
the program, I guess.
What do you think?
I have no idea.
If this projector breaks, if this projector breaks, think about it. It doesn't affect me. Well, the procedure's probably still the same. Hit the dim button, right? Okay. Data's still the same. The software's still the same. They can swap that out in a matter of minutes. Yes? That monitor cracks. Boom. No big deal, right? Hardware is the easiest thing to change. So increasing degree of difficulty, the more we're on the human side, the more difficult it is. You know, people don't like to change. They don't like to change the way they do things, right? So how do we combat that? Organizationally, we do what we try to get them to have buy-in. We do training, right? We say, hey, this is what you're going to have to do in the new system. This is why it's better. All those things come into play. Automation moves work from the human side to the computer side. We increase the degree of difficulty when we're on the people side. What do you think is the most important component of this information system? Come on, we're narcissistic. So what do you think? What do you think? What's the most important component? Yeah, people. People, right? The reason it exists. People need to accomplish tasks. They're the most important. Now, all the components have to work. All the components have to work or the information system is no good. And in fact, if we have an issue, okay, we have a problem with our information system, you can use the 5-component framework to say, where is the problem? You know, maybe our payroll system is, you know, we're getting erroneous results from our payroll system. You know, people aren't being paid the proper amount. Well, look, we can take the 5-component framework and figure out what's happening. Well, is there something wrong with the hardware? Probably not, right? Maybe if they're not getting anything, well, yeah, there's something wrong with the printer. Okay, that could be the problem, right? That's hardware problem. They're not printing out, or they're too light, or whatever it might be. Could be a software problem. Maybe when we're multiplying for tax, we're multiplying by 60% instead of 6%. That's a software problem, right? That's why the information system isn't working. Could be a data problem. You know, maybe we have the wrong table of tax codes in there. You know, that we got, maybe it's an old table of tax codes. Could be a procedures problem. Maybe when people are entering their time in, you know, they're not accounting correctly for their vacation or their hours worked, so they're not using the system correctly. Or it could be a people problem, you know, not just the procedures, but the people, you know, maybe they're not doing what they're supposed to do. Maybe they're not entering their timesheets at all. So when we have a problem with an information system, this can be very useful to analyze, you know, where is the problem? Not just, hey, we have a problem, but think about the 5-component framework and where is the problem originating from. It can also help us, and you will be tasked with this sometime in your lifetime, I am sure, business is driven by technology. Many, many businesses are driven by technology. You'll be tasked with putting in a new information system. And understanding the scope of a new information system can help you price it, right? It's not just about buying the hardware, not just about buying the software. Putting in a new information system, you need to train people, right? That's part of the cost of the information system. All those things help you understand the scope of this new information system. All right. I'm going to move one more thing, and then we're going to wrap this up with a little exercise. So another way, so we can talk about information systems as just period systems, right? You can talk about them as systems, purpose, inputs, outputs, boundary, environment. You can just look at it as a system. You can look at a lot of things as a system. I'm glad. We can use the 5-component framework, which is what? Hardware, software, data, procedures, and people, to kind of analyze a system. The other way we can analyze an information system is by looking at the functions of the system. And we can break it out into like 6 functions. And these things are just different lenses looking at the same thing. Every system captures, okay, like captures data somehow. Give me an example. How does the Sheets ordering system capture data? Yeah, it's capturing this one. How are you capturing? If you're taking notes right now on your laptop, how are you capturing data? Your keyboard, right? Okay. Scanners, RFID. All those things are capturing devices, right? Typically hardware. Keyboard, barcode scanner, document scanner, optical character recognition, sound recorder, video camera, voice. That's all things that are capturing data. You know, we talked about our parking meter system. The scanning in the barcode. Scanning your credit card. That's capturing data. Putting your license plate. That's capturing data. To be useful, in many cases, it's important for us to be able to transmit, which means move the data. Okay? When you type in a Google search, right, your browser is capturing that data, but it's not really useful if it stays here. But if we take that submission and it goes to Google servers, in Ashburn, Virginia, transmits over the internet, comes back, and gives us the results, that is powerful stuff. So any kind of networking technology, broadcast TV counts, any kind of network, fiber optic, fax, anything that moves information, that's a transmit function. These two kind of go together. Store and retrieve. Okay? Systems capture data, and it's a good thing to store it forever. Data is cheap now, right? We can store information everywhere. You can buy a terabyte hard drive for $40, $50 now. It's unbelievable how cheap data storage is. So if we think about the Sheets MTO ordering system, it's storing in their system your order, right? And then it's transmitting it to the back of the person so they can see the work. It's also transmitting it to the point of sale system. So when you go up there and you show them your receipt, they can scan that in using capture technology and say, hey, here's your charge. Swipe your card, another capture. Transmits that transaction to your credit card company, deducts your balance. You think about that. All that is happening when you get a little hungry. Think about all the data that's moved through a couple systems when you do that. So store and retrieve, storing data and retrieving data. So anything like a hard drive, a thumb drive, an optical disk drive, anything that can store. Paper is a storage mechanism. Not a great storage mechanism because paper burns, paper fades, but it's a storage mechanism that you can retrieve later. We've used mostly computer stuff now. And the last two, manipulate. If you think about manipulate, you think about software. Okay? Manipulate means changing, adding, summarizing, sorting, multiplying, rearranging, reformatting, all those things, changing the data. Changing the data, why? To create information, right? To figure out a grade point average, to figure out the average sales at the cart of coffee in a day. That's what manipulation does. And finally, the last one is display, showing the person something. Laser printer, computer screen, showing something to the human, the person in the information system. So here's what I want to do. Okay, looks like we have about 20 people here. We have about 12 minutes left. So I'm going to give you guys a system. Let's say I will break you up into, so we don't have to move. Every 3 people are a team, right? So it'll be JJ, Myers, Natalie will be a team, your team 1. And the system that I want you to analyze is what we've done a little bit already, is ATM as a system. So I want you to look at it as purpose, inputs, outputs, boundary, environment. I want you to look at it as hardware, software, data, procedure, and people. And I want you to look at these 6 components, right? So all 3 lenses. You guys know what I'm saying? Okay, the next 3, Sean, Jacob, and Nancy, you guys are the student course registration system. You use it St. Francis. My Francis system, okay? All right. Taylor, Alex, and Alexis, you guys are a payroll system. Sarah, Marcus, and Elena, you guys are, let's say, Amazon. Aaron, Stephanie, and Stephen, Tinder. Okay. Eric, Mark, right? And you'll do a work order system. Like, you ever submit a work order at St. Francis? Do you guys know what I'm talking about? Like, something breaks and you need to submit a work order? You know what I'm talking about? Never broke. Huh? You never broke anything? Maybe this is yours, so you're all right. Email. You two do email. Okay. Go ahead, now. We're just talking plain old Amazon web interface, yeah. Not like streaming, yeah, I know you're.
So the input would be like the person showing.
I said we